games, you can play this, and the shadow is a projection of real object. Projection is of lower dimension. And in lower dimension, you begin to see a 120 bond angle. So breaking this so-called rigid view on a tetrahedral carbon, 100.9, yes, it is the internal bond angle, but when you project, you don't see that 100.9, you see 120. And that 120 is so critical that they begin to appreciate what is a conformer. Staggered eclipse, staggered eclipse, staggered 1, eclipse 1, staggered 2, eclipse 2, staggered 3, eclipse 3, you completed the entire 360-degree rotation. And in the process, I am introducing conformational analysis. And I am introducing an idea of carbon-carbon single bond can rotate. In fact, I will take one more step and say how fast it can rotate, how much energy it takes to rotate. This is another model, it is not Darling model. This is called riding model. Beautiful thing about this model. By the way, again, stories after stories. This model is more than 60 years old. 60 years, 60. 60 years old, you can hold it in your hand, you will see not a trace of rust. This model is 60 years old, inherited from a retired scientist from National Chemical Laboratory in Pune. He was about to discard and I jumped on it. For me, this is a very, very strong teaching aid. Okay, so what? This standard versus eclipse is not good for a very large auditorium, but I circulate this in the class. My TAs will be there, they will take this around and then pass from one student to next. So they will be chatting, they will be commenting. I don't care about the noise, but it gets registered. So what is the next point to be registered? In carbon-carbon single bond can undergo free rotation, fast rotation. Now how do I demonstrate? You see how fast it rotates. Free carbon-carbon rotation is so fast, it's a physical demonstration. It rotates so fast, so free, and this fan kind thing, it gets registered. And then slowly, conformational analysis, there is some merit in what he is saying. There is some value addition in what he is saying. Oh, carbon-carbon rotation is, free rotation is possible, and it can rotate so fast, and then I will give them a number so that it becomes quantitatively appealing. At room temperature, assuming 25 degrees Celsius, the number of rotations per second, in ethane, that number of rotation per second is something of the order of 10 to the power 12. 10 to the power 12 rotations. You look at the frequency of rotation, unbelievably fast. It gets captured by 1 to 2% of the class, and 50% of the class would appreciate CC rotation is very much possible, and it rotates fast. They don't care about the number, but it rotates, it can rotate